Hi everyone, these are the notes on angle proofs. So this is the lesson we did last week. Angle proofs are just like segment proofs, except now there are more properties that use angles rather than segments. So some of the same ones are used, like up at the top here. Oops. Up at the top here, congruence of angles is reflexive, symmetric, and transitive. So that just means that the reflexive property, symmetric property, and transitive property will work when you're referring to the congruence of angles. So remember, reflexive property right here is when an angle is congruent to itself. So like a mirror image, think of like a reflection. Symmetric property is when the left side and the right side just switch spots. So it's really just saying the same thing, but just in a flipped order. Transitive property is the one that sometimes is tricky to see. Transitive is when you have two angles. So in this case, it's angle 1 and angle 3 that are both congruent to angle 2. So if 1 and 3 are both congruent to 2, then they are congruent to each other. And that's transitive property. Transitive property of equality will only have 3 angles involved or 3 segments. It's the one that they're both congruent to is sort of like a link between, so in this one, like 2 and 3 is sort of like a link between 1 and 3. Okay, they're both equal to 2, so now they're equal to each other. So that's those first theorems. We already know those though. So now the rest of these, none of these are new. They're just, we haven't used them in proofs yet. So some of them are similar to ones we did in segment proofs. So to start, we have angle addition. Angle addition postulate is pretty similar to segment addition postulate, except now instead of adding small segments to a bigger segment, we're adding smaller angles to a bigger angle. So why don't we draw a picture for this? We can draw it right in here. Let's draw angle ABC. And then with a ray BD. And we'll call these angle 1 and angle 2. So angle addition, we take the two small angles, so this angle 1 and angle 2. If we add those two together, it gives us the whole angle, angle ABC. So what this would look like in a proof is you would have a picture like this where you have two angles next to each other inside of a bigger one. And what it would say in the statement would be something like this. The measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. Okay, that would be angle addition. The next one is definition of angle bisector. So this one would only be used if in the given information they said something about there being an angle bisector in the picture. So it would be something like this. Let's draw a picture for this one as well. I'm going to call this one XYZ. And then let's do like ray YW or something. So if I said ray YW bisects this angle, we should remember that bisect means to cut in half. So that would make these two angles congruent. So let's call them 3 and 4. So if I said ray YW bisects angle XYZ, what would happen in the next step is it would say angle 3 is congruent to angle 4. So to fill in on this left side, if a ray bisects an angle, then two angles are congruent. If we want, we can add in over here, like specifically for this picture, like ray YW bisects angle XYZ. Therefore, angle 3 is congruent to angle 4. Those three little dots mean therefore. Okay, so that's angle bisector. Again, you never want to use definition of angle bisector if it doesn't say anything about there being a bisector. Okay, you can't just start making stuff up if you have two angles congruent. Okay, complementary. We should remember complementary angles. If a pair of angles are complementary, then their measures add to 90 degrees. So again, it might tell you in the given, say like angle 1 is complementary to angle 2. Then later on in the proof, it would say something like the measure of angle 1 plus the measure of angle 2 equals 90. So if a pair of angles are complementary, then their measures add to 90. Okay, so that's if you have complementary angles. Next is definition of perpendicular lines. So this actually comes up sort of often. If lines are perpendicular, and remember this is the symbol for perpendicular, it's like an upside down capital T, so we have to think about what the definition of perpendicular is. So hopefully we remember that the definition of perpendicular, it's lines that intersect to form right angles. So if lines are perpendicular, then we have a right angle. So like, for example, you might see something like this. So if you were given that ray BA is perpendicular to ray BC, we could say that angle ABC is a right angle. Okay, that's what it would say. It goes perpendicular, then it says it's a right angle. Now, if we have a right angle, moving on to the next one, what is a right angle? Remember that a right angle is an angle that measures 90 degrees. So once they tell you that an angle is a right angle, next they would say that the measure of that angle is 90. So it says definition of a right angle, if an angle is a right angle, then it measures 90 degrees. There's an example of how these are used, I think on number 3 on these notes. So we will get there. Okay, that's the left-hand side. Whoa. If we come over to the right. Okay, here's some more. Definition of congruent angles. So definition of congruent angles is used just like definition of congruent segments. If we had, say, something like this. So say if angle 2 is congruent to angle 3, then they would say the measure of angle 2 is equal to the measure of angle 3. So that would be the definition of congruent angles. Remember with this, if we change the symbol, so see how the symbol was congruent symbol and then it switched to equal sign. Also, the M's are now here. Okay, so that's what tells us its definition of congruent angles. You want to look for just the switch in symbol and then either M's to no M's or vice versa. Okay, definition of a linear pair. So how it works with linear pair is oftentimes in a proof, you will be given that two angles form a linear pair. So if a pair of angles forms a linear pair, then the angles are supplementary. That's what they always say next. They say they're supplementary. How do we know that? Because of the definition of a linear pair. So let's fill in here. If a pair of angles form a linear pair, then the angles are supplementary. Okay. After they say that the angles are supplementary, think about what we know about supplementary angles. We know that their measures add to 180. So once it's stated that angles are a linear pair, we then say that the angles add to 180. So if a pair of angles are supplementary, then their measures add to 180. Excuse my dogs barking. Not sure if you can hear them. They're just barking up a storm. Okay, so that's definition of supplementary angles. Now the last two, substitution property of equality and the addition and or subtraction property of equality, these are used in the same way we would use them in segment proofs. So remember substitution, we can like replace whole angles or expressions for one another if we know they're equal. Addition, subtraction would be if we are adding or subtracting the same angle from both sides. So these are used in the same way as segment proofs. So we can write for substitution property of equality, we can say if angles or expressions are equal, we can replace them for one another. Okay, that's substitution. The addition property of equality would be if we add the same angle to both sides. Subtraction property of equality would be when you would subtract the same angle to both sides or from both sides. So those are used in the same way as we did with like algebraic proofs or segment proofs. Okay, so I'm just going to zoom out so you can see everything that we wrote on here. Give you a second to add stuff in, or pause it here if you need to fill in some from before, if you missed any. Okay, so let's go down and do this first example. In this example 1, we are given that angle 1 and angle 3 are supplementary, and that angle 2 and angle 3 are supplementary. We are asked to prove that angle 1 is congruent to angle 2. So, as you can see, we restated the given information for step 1, so reason number 1 would be given, as always. Okay, step 2 says the measure of angle 1 plus the measure of angle 3 equals 180, measure of angle 2 plus the measure of angle 3 equals 180. So we want to ask ourselves, how do we know these angles add to 180? Well, look up above. We were just told that they were supplementary, and we know the definition of supplementary is angles whose measures add to 180. So the reason for number 2 would be the definition of supplementary angles. Okay, so that's number 2. How do we know they add to 180? Because we know the definition of supplementary. Now looking at number 3, we have angle 1 plus angle 2, angle 1 plus angle 3 equals the measure of angle 2 plus the measure of angle 3. So how do we know that 1 plus 3 equals 2 plus 3? Well, up in step 2, they're both equal to 180. So basically what they did is they took measure of angle 2 plus measure of angle 3 and plugged it in here for 180. Okay, so remember when you move segments or angles or expressions around, that's substitution property. So because 2 plus 3 is equal to 180, I can replace 180 with measure of angle 2 plus measure of angle 3. So that's substitution property of equality. Okay. Step 4 says measure of angle 1 equals measure of angle 2. So we want to ask ourselves what happened there. How did we get that? If you look at step 3, notice there was the measure of angle 3 on both sides, and now all of a sudden they're gone. So what we did is we subtracted the measure of angle 3 from both sides. Then they canceled, and we were left with measure of angle 1 equals measure of angle 2. So that would be subtraction property of equality. Okay, and the last step says angle 1 is congruent to angle 2. So remember from 4 to 5, notice the only thing that has changed is the equal sign turned into a congruent symbol, and then the measures were taken away. So this would be definition of congruent angles. Okay, so substitution is the same as segment proofs. Subtraction is the same. Definition of congruent angles is very similar. Okay, we always start with the given still. So that's number 1. Okay, let's go to the next one. Okay, so here is example 2. Example 2, we are given that the angle EDG is congruent to angle FDH, and we are asked to prove that angle 1 is congruent to angle 3. So, just like before, to start off, we are going to restate the given. So they said angle EDG is congruent to angle FDH, so that's given. Number 2 says the measure of angle EDG equals the measure of angle FDH. So we want to think about what happened from step 1 to step 2. The m's were added on, and also the symbol change. So the symbol changed from a congruent symbol to an equal sign. So when that happens, that's because of the definition of congruent angles. So how do we know the measures of these angles are equal? Because we know what the definition of congruent angles is. Okay, so the next one says the measure of angle EDG is equal to the measure of angle 1 plus measure of angle 2. So this is the first time now that they've brought in the numbered angles. So that tells me that it didn't come from up above, and I should maybe look at the picture to help me. So if you look at the picture, it says EDG, so EDG is here, is equal to 1 plus 2. And then it says FDH, this one here, is equal to 2 plus 3. Okay, so this is the one where you're given one big angle, and it says it's equal to the two smaller ones inside being added together. So what would that one be? If you said angle addition postulate, you are correct. So this is angle addition postulate. Just like segment addition, but with angles instead. Okay, now for step 4, it says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. So if you're not sure what this is, I want to look at, okay, angle 1 plus angle 2, where have I seen this before? Oh, I've seen it up here. Okay, 1 plus 2 is equal to EDG. Notice how, give me one sec, just want to erase this. Notice how EDG is right here. So basically what we did is we took 1 plus 2 and we popped it in here for EDG. Then we did the same thing with 2 plus 3. 2 plus 3 right here, I've seen, well, this one rather. 2 plus 3 I've seen up here, and it's equal to FDH. So I just took that and popped it in on this side. So that's how I ended up with the measure of angle 1 plus the measure of angle 2 on the left, and the measure of angle 2 plus the measure of angle 3 on the right. I moved them around, I substituted them. So that's the substitution property of equality. Okay, and now lastly, step 5. So from 4 to 5, notice that angle 1 is still on the left, angle 3 is still on the right. Only thing that's missing is that measure of angle 2 from each side. So what did we do to get rid of it? We subtracted. So we subtracted the measure of angle 2 from the left-hand side and the right-hand side. Okay, so now that's the subtraction property of equality. Okay, this one, I actually was missing a step in the typed version of this. Notice that we're not quite done yet. It just says measure of angle 1 equals measure of angle 3, when really up in the prove, they wanted us to prove that angle 1 is congruent to angle 3. Okay, so I messed up on the typed version of this, but we have to add in a step 6, which matches the prove, which is angle 1 is congruent to angle 3. And hopefully we are good at this one by now, and we know that it's definition of congruent angles. So the symbol changed, the M's have gone away. So definition of congruent angles. Okay, so that's number 2. We use some angle addition, some substitution, some subtraction. Notice a trend here. It's kind of the same ones used often. Okay, so I'll leave this here for a sec in case you need to pause it to fill in. Okay, let's take a look at the last one, number 3. Example 3, we were given that ray AB, so ray AB is right here. Ray AB is perpendicular, that's what this means, perpendicular to ray BC. Okay, we have to know what that symbol means if we don't know that already. And then it says that angle 1 and angle 3 are complementary. So think about what that means. They want us to show that angle 2 is congruent to angle 3. So statement 1 says that ray AB is perpendicular to ray BC. You might want to write in that that means perpendicular if you weren't sure. Okay, so this is given. Hopefully we notice that there were 2 pieces of given information, what they just listed in step 1, and also that 1 and 3 are complementary. Notice that that is not listed in step 1. sometimes, and I don't know if this has happened quite yet, but sometimes in proofs, they split up the given information. So they'll maybe give you 2 or 3 pieces of given information, but they only restate one of the pieces first. So then that means that 1 and 3 are complementary is going to be somewhere further down the proof. So you might want to look for that now. Do we notice that it's right here? Okay, so that means that step 6 will also be given. Okay, so let's get started. Step 2 says that angle ABC is a right angle. So then we want to ask ourselves, how do we know that this angle right here is a right angle? Well, it said that AB and BC were perpendicular, and perpendicular lines are lines that intersect to form right angles. So that would mean that ABC is a right angle. So how do we know it's a right angle? Because we know the definition of perpendicular. This one kids forget about a lot, so hopefully we can remember this. Definition of perpendicular makes right angles, basically. Okay, and then in step 3, how do we know that the measure of angle ABC is equal to 90? Well, in step 2, it said that ABC is a right angle. What is the definition of a right angle? An angle that measures 90 degrees. So step 3 would be definition of right angle. That's how we know that it measures 90 degrees. Okay, now step 4 says the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. Let me erase some of this up here. So if we look at the picture, ABC is equal to 1 plus 2. Notice ABC is a bigger angle and 1 and 2 are inside of it next to each other. Remember, that is angle addition, when you have a bigger angle with some smaller angles inside of it being added together. So that's why ABC equals 1 plus 2. That would be the angle addition postulate. Okay. And now step 5, the measure of angle 1 plus measure of angle 2 equals 90. So this one is a combination of steps 3 and 4. Notice how 1 and 2 added together is equal to ABC, and also 90 is equal to ABC. So basically what we did is we took 1 plus 2 and plugged it in up there for ABC. So we did some substitution property. Okay, so now the reason why sometimes they split up the given is they'll list the first piece of given information and then they'll like pretty much do like everything they can using that given information, so using the perpendicular lines, and then they move on to the next piece of given information. So 1 and 3 are complementary is next, and now we're going to list everything we can about that. So remember that complementary angles are angles that add to 90. So in the next step, notice they say the measure of angle 1 plus the measure of angle 3 equals 90. How do we know those two angles add to 90? Because we know the definition of complementary angles. Whoops, complementary angles. Okay, so that's step 7. Okay, I'm going to erase some of this writing up here so we can finish the rest. Okay, number 8 says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. So again, if you're not sure where this came from, you kind of want to look up above and look for, like, where do I see 1 plus 2? Where do I see 1 plus 3? Notice that in 5 and 7, 1 plus 2 is equal to 90, 1 plus 3 is equal to 90. So now we can say they're equal to each other. So again, this is substitution because we took 1 plus 3 and plugged it in there for 90. So anytime you're moving around angles or expressions, like that means like 2 angles being added together, that would be substitution. Okay, now step 9, if you look at from 8 to 9, something happened. do we notice that angle 1 is gone? So we subtracted angle 1 from both sides, and that's what left us with angle 2 equals angle 3. So watch, this is what they did. So we did minus measure of angle 1, minus measure of angle 1, gone. Okay, so we subtracted angle 1 from both sides. So that's the subtraction property of equality. And then last step, measure of angle 2 equals measure of angle 3, and then it goes to angle 2 is congruent to angle 3. So for that last step, the symbol changed. It went from equal sign to congruent symbol, and then the m's were gone. So anytime that symbol changes, it's definition of congruent angles. And that's number 3. That was probably the longest one. Had kind of a lot going on, but you see ones like this kind of often, I would say, that have like complementary or perpendicular involved. Remember that substitution, I would say, is used in almost every proof that we're going to do. Is often moving stuff around in proofs. That's how we a lot of times are able to prove what we're being asked to prove, because we can substitute. So that's it for this lesson. If you have any questions, feel free to email me. I will be checking often to see if you guys have questions. Hopefully this helps you to be able to complete the work that I left for today. So again, email me, and thanks for watching.